welcome back to my channel. Today we'll be looking at what we call the arithmetic progression. As discussed before, or we can call it the arithmetic series. As discussed before, a series is the sum of the terms inside a sequence. So you would have been introduced to the arithmetic sequence already. So let us see what this would look like. So my series, I'm going to call it Sn. We know that in the arithmetic progression, the first term is A. The second term, we add the common difference to the first term to get the second term. So the second term is A plus D. The third term is going to be A plus 2D. And of course, you would pick up a pattern here, because if the first term is A, the second term is A plus D, the third term is A plus 2D. Let us say, for some reason, we wanted the 21st term. This would be A plus 20D. As you can see, if we're talking about the 21st term, it would be 20D. So the coefficient of D is always 1 less than the term that you're interested in. And that is something important to note. Well, let us say that we skip out a few terms. And we probably wanted, let me start with the last term. So the last term would be A plus n minus 1 times D. This would be my last term. The term before the last term, which is the second to last term, would be A plus n minus 2 times D. And if we want to talk about the third to last term, it follows a similar pattern. Let me just create some more space here. It would be A plus n minus 3 times D. So this is basically how we get all the terms. So we have A, which is the first term, A plus D, the second term, A plus 2D being the third term. We skip out a few. The third to last is A plus n minus 1 times D. Second to last is A plus n minus 2 times D. And the last term is A plus n minus 1 times D. Now, what we want is a formula that can find the sum of any amount of terms in the arithmetic progression instead of writing them out individually and adding them. Now, how do I do that? Let me show you just a quick arithmetic progression and show you how unique this is. So let's say we have 2 plus 4 plus 6 plus 8. Of course, this is arithmetic because I'm constantly adding 2 each time. Now, notice if I were to, let me call this series S. If I were to take the same series and I were to turn it around, I would have 8 plus 6 plus 4 plus 2. But here's where the magic happens. If we were to add these two series, I would have 2s equal, now notice that 8 plus 2 is 10, 6 plus 4 is 10, 4 plus 6 is 10, and 8 plus 2 is 10. So what do we realize? Is that if we turn the arithmetic series around and we add it to the original series, what is going to happen is that the sum of the values will all be the same. What does that mean for me? What it means is that I have 2 times the series. So if I have 2 times the series equal, that would be 40. If I want the sum of the series, I would simply just divide both sides by 2. So S is equal to 20. And you realize that with this pattern, of course, I could generate a formula for finding this. Because notice that I have 1, 2, 3, 4. I have 4 tens and I simply just divided it by 2. So that is the concept we're going to be using to sum or to derive a formula for the sum of the arithmetic progression. So let's go back to this. So we're going to be following the same pattern. So we have written out the series already. We're going to take the same formula and we're going to write it in reverse. So I'm going to write the last term first. The last term is A plus n minus 1 times D. This is my last term. Then I'm going to add the second to last term, which is A plus n minus 2 times D. Then I'm going to add the third to last term, which is A plus n minus 3 times D. And I'm going to skip out a few terms, and I'm going to go to the third term, because remember we're going in inverse, which is A plus 2D. I'm going to go to the second term, which is A plus D. And then I'm going to go to the first term, which is just A. Now, let us say we decide that we want to add the series, similar to how we did with the numbers. I would have 2Sn So let me just draw the line there, and we add it. I would have 2Sn. Now notice if I were to add a to a plus n minus 1 times d, what I would really end up with is 2a plus n minus 1 times d. Plus, if we add a plus d to a plus n minus 2 times d, a plus a is 2a, and d plus n minus 1 times d would make it one more d, so I would have n minus 1 times d. So once again, I would have 2a plus n minus 1 times d. Similarly, if I do the same thing here, if I add the third term to the third to last term, I would have 2a again, and then 2d plus n minus 3 times d is n minus 1 times d. And you realize that if I keep doing this, I'm going to end up with the same thing. So I'm still going to have this going right up to the n, which is 2a plus n minus 1 times d. And this goes up to the very last, when we add the last term and the first term. So what we can say is that 2Sn equal, and the number of time I would have this would be equal to the number of terms that you'd have seen with the numbers. So what I would have is, instead of writing this so many times, so if you have 4 times 6, or if you have 6 sixes, you wouldn't write out that as 6 plus 6 plus 6. You'd write that as 6 times 6. Or if you have 4 of them, you'd write that as 4 times 6. I have n of these sums. So I'm going to have n, open bracket, 2a plus n minus 1 times d, close bracket. But what do I really want? I want the sum, which is Sn. So I'm going to have to divide both sides by 2. So we can say Sn is equal to n over 2, open bracket, 2a plus n minus 1 times d. And this is the formula for the sum of n amount of terms in an arithmetic progression, or we can call it an arithmetic series. Very powerful formula here, and we're going to show you how we use it. Now here's an example. Find the sum of the first 20 terms of the series 11 plus 25 plus 39 plus 53. Now before I start applying the formula, I would first have to check to ensure that this is actually an arithmetic progression. So we have, how do we know that? We know that if we are constantly adding a common difference. So we have 11, 25. I would have added 14 to 11 to get 25, add 14 to 25 to get 39, and I add 14 to 39 to get 53. So when I'm constantly adding a common difference, I know that this is an arithmetic progression. Now note, I could have been asked to prove that this is arithmetic. Alright, all I would have to do is to show that when I subtract any two consecutive terms, I would have gotten the common ratio, which is 14. So let me just go ahead and do that. So if they had asked you to prove that the thing is arithmetic, we would have to show that the common ratio, which is d, is equal to the difference of any two consecutive terms. What do I mean by that? If I were to take the second term and I were to subtract the first term, I should get the same result if I take the third term and I subtract the second term. Let us see if this is true. So d would be equal to, the second term is 25 minus the first term, which is 11, should give me the same result as the third term, which is 39, minus the second term, which is 25. So we end up with 14 equal 14. So indeed, this is arithmetic. So if you were asked to prove that this thing is arithmetic, this is the approach you'd have to take. We didn't directly have to use the second term and the first term. We could have used the fourth term and the third term, but they must be consecutive terms. Now let us get into what we want to find. We want the sum of the first 20 terms. So we can start by writing down the formula that says Sn equal n over 2 into 2a plus n minus 1 times d. Alright, now let us remind you what the different components are. N is the number of terms we have, a is the first term, and d is a common difference. So I want the sum of the first 20 terms, so we could say S20 would be 20 over 2, open bracket, 2a, which is 2 times the first term, and the first term of course is 11, plus n minus 1, so that's going to be 20 minus 1 times my common difference, which is 14. Now the rest of this is just a matter of breaking this down using your calculator. So we would have 20 over 2, which is 10. Alright, we could actually work out all the brackets and then we multiply. Bracket works out to be 288. So when I multiply this, I'm going to get 2,880. So if I were to add up the first 20 terms in the series, I would end up with 2,880 as my answer. Now here's example number 2. It says evaluate the sum of 2r plus 3 from r equal 1 up to 14. What this really means is that we want the sum of the first 14 terms of the series. Now, we do know that this is arithmetic, and it's easy to know that this is arithmetic. Once the expression inside the bracket is actually linear, that is one way to know that the thing is arithmetic. But because this is the first example, I'm just going to write down the first 3 terms to show you. So we could call this Sn equal, to get the first term I would put in 1, so I would have 2 times 1 plus 3. 2 ones 2 plus 3 is equal to 5. To get the second term, I would put 2 into this. So it would be 2 times 2, which is 4, plus 3, which is 7. To get the next term, I would put in 3 in there. So it's 2 times 3, which is 6, plus 3, it gives me 9. And this would continue on and on and on. I could actually write out the first 14 terms and add them up, but that would take some time. Because note you can write it out and add it up. But once I realize that this is arithmetic, and it has quite a few terms, I could go ahead and use a formula that says that Sn equal n over 2 into 2a plus n minus 1 times my common difference d. In this case, my first term is 5, and my common difference is 2, as you can see. I'm going up by 2. We're talking about 14 terms, because it sums from 1 to 14. So this would be equal to 14 over 2, open bracket, 2a, which is 2 times 5, plus n minus 1. So that's 14 minus 1. So we know that that's going to be 13. So we can either put 14 minus 1, or we put 13 times d, which is 2. Alright, and you know, of course, your calculator can take care of all this. So this is going to be 7. And if we work out the bracket, I'm going to have 2 times 5 is 10, plus 13 times 2 is 26, which is going to be 7 times 36, which boils down to be 252. Alright. And we opted to do a second example of this because it is not every time that the sigma notation starts from r equal 1. Now what happens when we start from r equal 5? What it means is that to get the first term, I would have to put 5 inside of the sequence right here. So let me say that Sn be equal, if I were to input 5, I would have 3 times 5, which is 15, minus 1 is 14. Then to get the second term, I would have to input 6. So 3 6 is 18, minus 1 is 17. To get the third term, I would now have to input 7. So I would have 3 7s 21, 21 minus 1 is equal to 20. And this goes on and on and on. Now the important question here is how many terms do I have? So because we start from r equal 5, to get the number of terms that we have, we would have to subtract 5 from 20 and add 1. That is to include r equal 5. So let me just write something here. So we could say n is equal to 20 minus 5 plus 1. Alright? So 20 minus 5 is 15, 15 plus 1 is 16. So we have 16 terms. Once we establish that, we can go back to the formula and say Sn equal n over 2 into 2a plus n minus 1 times d. Good. Now, of course, there's a next way that I could have done this. Alright? And let me just put a column here. Let me write this out first before we show you what's happening. So we could say that Sn, we say that we have 16 terms. That would be 16 over 2 into 2a. First term is 14. And since we have 16 terms, 16 minus 1 is 15 times my common difference. And my common difference would be 17 minus 14, or we can say 20 minus 17, which is equal to 3. All this boils down to 8 multiplied by my bracket. So this is 8 times 73, which is going to break down to 584. Alright? So that is one way to look at it. Here's a second way that I could have looked at it, and it's a bit longer. Alright, since we want this thing to start from 1, because the formula represents the sum of the first n terms, right? We want it to start from 1. This is starting from 5. What I could do is to say that Sn equal, we simply take the sum of all the terms from 1. So if I'm going from 1 to 20, it would be S20. Now, what we do is subtract what we don't want, which is the first 4 terms. Alright, so if we're going from the 5th term up to the 20th term, we don't want the sum of the first 4 terms. So I just say minus S4. This is one way to look at it. And there will be scenarios where you actually have to do this. I'm going to look at an example of that right away. Here's an example of an interesting question. It says find the sum of the first 100 odd numbers. Alright, and we know what odd numbers are. So let me start by writing out a few odd numbers. So I have Sn equal, we know that the first odd number is 1, then 3, then 5, and this goes on and on and on. So we realize that this, of course, is an arithmetic progression, because notice we're constantly adding 2 to get each odd number. So I would have Sn in the formula equal n over 2 into 2a plus n minus 1 times my common difference d. So this would actually be equal to 100 over 2 into 2 times my first term plus n minus 1 is 100 minus 1, so it's 99 times my common difference, which is 2. So this would be equal to 50 multiplied by times 200, which is equal to 10,000. So this is part A, alright? Now it says part B, hence find the sum of the second 100 odd numbers. Now here's the problem. Now I could do a similar concept, but no, in order to work this out, I would have to know where the second 100 odd numbers start from, which is going to be a bit technical because the first one is not going to be 101. Alright, because remember, inside of 100, from 1 to 100, you have 50 odd numbers. And then from between 100 and 200, inclusive, you have a next 50. So you'll have to figure out what the 101 odd number is. Now that is going to be technical and that is going to take some time. But here's an easy way to look at it. It is easy to sum the odd numbers from the first odd numbers up to a point. So if I want the sum of the second 100, I could find the sum of the first 200 and then I could subtract the sum of the first 100. So what we're saying here, let me call this part B. We want the sum of the first and the second 100 odd numbers. I could find the sum of all 200 odd numbers and subtract the sum of the first 100, because this would be easier. It would be more difficult to just find the sum of the second 100 because you'll have to figure out what the first odd number is in that range, or what the 101 odd number is, and we'll start and work our way up, which you could figure out, I'm sure, but it's easier this way. Now we already have the sum of the first 100 odd numbers to be 10,000. So let us talk about the sum of the sum of all 200 odd numbers. So using the formula, this would just be 200 over 2 into 2a, because we're talking about all 200 again, we're going to be starting at 1 as the first odd number. So it's 2 times 1 plus 200 minus 1, so that's 199 times my common difference. My common difference, of course, is 2. This boils out to be 40,000. So we can just write a statement that says, therefore, sum of second 100 odd numbers would simply be equal to 40,000 minus 10,000. Right? And this is equal to 30,000. So whenever you're in a scenario like this is always a good approach to take.